You can't break the laws of nature. There are no penalties for doing so. The real world, and this one, are merely so arranged that transgressions can't happen. The job of physics is to find out what those laws are. Before Einstein, physicists thought that there were privileged frames of reference, some special places and times against which everything else had to be measured. Einstein encountered a similar notion in human affairs, the idea that the customs of a particular nation, his native Germany or Italy or anywhere, are the standard against which all other societies must be measured. But Einstein rejected the strident nationalism of his time. He believed every culture had its own validity. And also in physics, he understood that there are no privileged frames of reference. Every observer, in any place, time, or motion, must deduce the same laws of nature. Caldo. A speed is simply how much space you cover in a given time, as any kid on a motor scooter knows. Since near the velocity of light, we cannot simply add speeds. The familiar notions of absolute space and absolute time, independent of your relative motion, must give way. That's why, as Einstein showed, funny things have to happen close to the speed of light. There, our conventional perspectives of space and time strangely change. Your nose is just a little closer to me than your ears. Light reflected off your nose reaches me just an instant in time before your ears. But suppose I had a magic camera so that I could see your nose and your ears at precisely the same instant. With such a camera, you could take some pretty interesting pictures. Paolo says goodbye to his little brother Vincenzo.
Ciao, Vincenzo. Ciao,
and rides off. He's now going more than half the speed of light. He's almost catching up with his own light waves. This compresses the light waves in front of him, and his image becomes blue. The shorter wavelength is what makes blue light waves blue. Also, Paolo becomes skinny in the direction of motion. This isn't just some optical illusion. It really happens when you travel near the speed of light. As he roars away, he leaves his own light waves stretched out behind him. Long light waves are red. We say that his receding image is red-shifted. Now, Paolo leaves for a short tour of the countryside. He experiences something even stranger. Everything he can see is squeezed into a moving window just ahead of him. Blue shifted at the center, red shifted at the edges. To a passerby, Paolo appears blue shifted when approaching, red shifted when receding. But to him, the entire world is both coming and going at nearly the speed of light. Roadside houses and trees that he's already gone past still appear to him at the edge of his forward field of view, but distorted and red shifted. When he slows down, everything again looks normal. Only very close to the speed of light does the visible world get squeezed into a kind of tunnel. You would really see these distortions if you could travel near the speed of light. Someday, perhaps, interstellar navigators will take their bearings on stars behind them, whose images have all crowded together on the forward view screen. The most bizarre aspect of traveling near the speed of light is that time slows down. All clocks, mechanical and biological, tick more slowly near the speed of light. But stationary clocks tick at their usual rate. If we travel close to light speed, we age more slowly than those we left behind. Paolo's watch and his internal sense of time show that he's been gone from his friends for only a few minutes. But from their point of view, he has been away for many decades. His friends have grown up, moved on, and died. And his younger brother has been patiently waiting for him all this time. The two brothers experience the paradox of time dilation. They've encountered Einstein's special relativity.
Vincenzo.
This was just a thought experiment, but atomic particles traveling near the speed of light do decay more slowly than stationary particles. As strange and counterintuitive as it seems, time dilation is a law of nature. Traveling close to the speed of light is a kind of elixir of life. Because time slows down close to the speed of light, special relativity provides us with a means of going to the stars. This region of northern Italy is not only the cauldron of some of the thinking of the young Albert Einstein, it is also the home of another great genius who lived 400 years earlier, Leonardo da Vinci. Leonardo delighted in climbing these hills and viewing the ground from a great height as if he were soaring like a bird. He drew the first aerial views of landscapes, villages, fortifications. I've been talking about Einstein in and around this town of Vinci, in which Leonardo grew up. Einstein greatly respected Leonardo, and their spirits, in some sense, inhabit this countryside still. Among Leonardo's many accomplishments in painting, sculpture, architecture, natural history, anatomy, geology, civil and military engineering, he had a great passion. He wished to construct a machine which would fly. He made sketches of such machines, built miniature models, constructed great full-scale prototypes. And not a one of them ever worked. Mainly because there were no machines of adequate capacity available in his time. The technology was just not ready. The designs, however, were brilliant. For example, this bird-like machine here in the Leonardo Museum in the town of Vinci. Leonardo's great designs encouraged engineers in later epochs, although Leonardo himself was very depressed at these failures. But it's not his fault. He was trapped in the 15th century. A somewhat similar case occurred in 1939, when a group of engineers calling themselves the British Interplanetary Society decided to design a ship which would carry people to the moon. Now, it was by no means the same design as the Apollo ship, which actually took people to the moon some years later. But that design suggested that a mission to the moon might one day be a practical engineering possibility. Today, we have preliminary designs of ships which will take people to the stars. They are constructed in Earth orbit, and from there, they venture on their great interstellar journeys. One of them is called Project Orion. It utilizes nuclear weapons, hydrogen bombs, against an inertial plate, each explosion providing a kind of putt-putt, a vast nuclear motorboat in space. Orion seems entirely practical and was under serious development in the United States until the signing of the international treaty forbidding nuclear weapons explosions in space.